Okay, and g prime of x, Ethan? Good, because the 5 would become a 0, right? So negative 2. Okay, now it's just a matter of plugging in d dx of f of g of x using the chain rule. F prime was what again? 20, but where the x is, what am I going to do? Plug in. So I put parentheses and I plug in. That's a 4 actually, huh? I plug in g, which is 5 minus 2x, times by g prime of x, which is negative 2. So parentheses would be important so it doesn't look like you're subtracting. 20 times the negative 2 is the last step we need to do there. So d dx of f of g of x equals negative 40 times 5 minus 2x, all to the 4th power. Or you need to say y prime. Okay. Why don't you guys try number 4? You've seen 2 now. Give number 4 a shot. Find your f, find your g. It might be easiest to start with g first, and then find your f. If you get stuck, your first resort is turn to your neighbor. The tricky part is just the beginning. Let's see what we're getting. Raise your hand if you think you're confident with what g of x would be. You confident? You confident? What do you think? Oh, so the stuff underneath the square root? I would agree. So I have my f of x, g of x. 3x squared minus 5x. That's my quadratic function. There's another function there too, right? Which is f of x. What's f of x, Jake? So the square root of x, or x to the 1/2, right? So we have your quadratic function is what's been stuffed into the square root, in a square root function. For the purposes of taking the derivative, it's easier to see it the way he told me, right? X to the 1/2. Okay, so go ahead and find your derivatives and then use the chain rule to take the derivative of y, or f of g of x. Okay, so this one, we bring down the 1/2. Then it'll be x to the 1/2 minus 1, which I'm going to put as 2 over 2. Okay, so there's a little bit more on that one. Good, okay. You got those right. Now I'll start plugging them in. F prime of g times g prime. Now, okay, f prime's the hard guy. I think we're all getting g prime. G prime is 6x minus 5. But f prime, careful. What is f prime of x, Hala? What's the derivative of f prime? To the 1/2 power. Okay, so d dx of f of g of x equals f prime, which is 1/2 x to the negative 1/2 power, but we stuff in g, 6x minus 5 times, oh, that's the wrong one, regular g. Regular g. Okay, regular g was 3x squared minus 5x times, I put this in the parentheses, 6x minus 5. Okay? Now, where does something that has a negative 1/2 exponent go? You could, or you just take it as its grouping and drop it to the bottom so it's positive. So in the bottom we have a 2, and we now have a square root, because isn't 1/2 power a square root? By bringing it down to the denominator, it's now positive. And what goes in the numerator? Nope. Well, we can put a 1, but we need some other stuff. 6x minus 5. Times by 1 if you want. Okay? What do you think? Questions or confusions on this one? Should we try another one? Gets better. We have lots of examples to do today. So all we're doing today is chain rule, chain rule, chain rule. Try number 5. I think finding the g of x first is easier. And then find the f. Take the derivative of each. Cosine what? Good. Yep. Yeah, you're done. Good. I would just move that times 3 to the front so it's negative 3 sine. But that's it. Good job. These are looking good. Good. I think everyone's got it. Good job, guys. Good job, guys. So we got negative 3 sine of 3x minus 4, right? We don't usually like to see that times by 3 on the right side. With the trig functions, we'd want the multipliers right before the sign. So make sure you move it over to the left. But for the most part, I think we all got it. Did you get it there? Good. Let's try another one. And this will also help us start memorizing those tangent functions, or the trig functions, tangent and secant. You have to take the derivative of those guys. Okay, try 6 and 7. Raise your hand when you think you have it, and I'll come check. Cool. 7's going to be fun. Way to exercise your brain so early in the morning. I had calculus first period too in high school. I wonder if it's like a thing. Because they know you guys will actually be on time for school versus everyone else who's not in AP is tardy for school. Though I was tardy to calculus every morning, so maybe I wasn't a good example. And we had a thing, if you had more than 2 tardies, you got a U, so a 0 in citizenship, and to make up your U, you'd have to spend 45 minutes in detention. So I was always tardy for calculus by like 2 minutes, and I spent every day 45 minutes in detention. You'd think like it'd go through my brain, 2 minutes versus 45 minutes. Raise your hand when you think you have number 6. Or if you want me to verify. So we get 4 and negative 3x squared, yep. Then, yep, that'll be positive secant squared. I think you are done. Yep, you are done. Box that up. Good job. And put a y prime equals or a dy dx equals.
What I just made is fine.
Nope, you're done. You can if you want, but you're done.
Good.
That's it. Yep, that's it. Yeah, you can't distribute those because the first parenthesis is part of this secant. So this is it. That's it. You are done. Good. Okay, let's see those. And you'll need like a y prime equals or dy dx equals. And I put this in parentheses. But then that's right. Wait, hold on. You have a 4. Yours is in a different order than mine. 4, that should be a 3. When you take the derivative of that, the 3 would come down. Okay. Good. Good job. The only thing we need to fix is this. The derivative of tangent is secant squared instead of cosecant squared.
Oh, yeah.
But then everything else is perfect. Yep. So that just needs to be secant, and you're good. Yep, you're done. Just put a y prime in the front. Yep. And that's it. Good, good, good. Try number 7. And I'll write 6 is the answer here, but I think everyone has it. Seven, okay. Yep, the only thing adjustment I would make is it's kind of funny to times something like that on the end, so I would just throw the 3 in the front, but it's equivalent, it's the same thing.
So does the 3 discrete
Nope.
the entire function, not the entire function?
Nope,
So
because this is a secant of this. So it's part of the secant function, so you can't times the 3 in that. I would just put the 3 in the very front like you did there. I think that's right. I just put that 3 in the front, yep, and that's it. Yay, you guys are doing so well. And everyone's like, you have to spend 2 days on chain rule. They're going to struggle so bad. But, well, flip it over. That's it. Yep, you're done. No, we don't want to do that. I mean, you can, but it's the same thing like our equations on the AP test. If it all asks us for an equation in any form is it. You can stop. Don't go further because you're going to end up maybe making mistakes. Cool. Cool. Flip it over. Try the next ones. In case you wanted to, I think I've checked most people's 7, but here's what we got for 7. If you're not getting this, I like the 3 in the front. The tangent and secant, can those be in any order? Because multiplication has the commutative property, we can multiply in any order. Could I have put secant first and then tangent? Yeah. Good. Okay. Interesting coming up. All right, number 8. Maybe we should do number 8 together. Is everyone ready for number 8? Okay, you can try it. Have fun.
Let's erase everything.
How many functions do you see in number 8? I see 3. I agree with that. Who said 3? Okay, Joanna, and I thought I heard a guy's voice. Jake, I see 3 functions. This is product rule and chain rule. That guy is being multiplied to the part, this part has the chain rule. Okay, let's refresh. Remember what the product rule is. Yeah. First, D last, plus, good. Last, D first. So it's the derivative of the last that you're going to have to do chain rule on. Okay, I might work that out first. Okay, the d dx of f of g of x of just 1 second. I want to see what I've been writing here. Have I just been... Oh, yeah, then I just wrote the whole thing. I'm like, I shouldn't write the function. Sorry, brain fart. Okay. So our f of x, if I just ignore the x squared for a minute, what's f of x? X to the 1/3, because it's the cubed function, or x to the 1/3. X to the 1/3 is easier to take the derivative of. And g of x is linear function. Yeah, 3x minus 1. Any problems or struggles with that? Okay, find f prime of x and g prime of x. Okay, read what's f prime. Good. Okay, and g prime, read. 3. Okay, so if we're just doing the chain rule, still ignoring the x squared, we'd have d dx of f of g of x equals f prime, which is 1/3 x to the negative 2/3, but in the x we plug in g, 3x minus 1 times f prime, which is 3. Ooh, look at those. Is there any way to cancel? Yeah, 3 and 3 cancels. And this becomes 1 over, ooh, which one's the index? The negative 2 or the 3? The number on the lip of the radical. Your grouping size is the 3. So cube root. This is a cubed root. Like a square root is 1 over 2. Okay, so this would be a cubed root of 3x minus 1 in parentheses squared. Because all of that was squared, but it was the cube root of 3x minus 1 all squared. Okay, but this is just the last. So now we do product rule. Oh my goodness, yep. First, what was the first? X squared. So we're looking for y prime now, so I'll put y prime. D last, we found D last. It's 1 over cube root 3x minus 1 squared. Plus, what's last? D first, the derivative of 2x squared. Or not 2x squared, x squared is just 2x. Okay, and you could stop there just to clean it up a little bit. I might put the x squared on the top of the fraction, cube root of that stuff in the bottom. How would we clean this up? Yeah, bring the 2x to the front, kind of like the sign thing. It's just weird to see something right after the radical, because then people will wonder, is it underneath the radical or is it not underneath the radical? So to make it clear that it's not underneath the radical, and also make sure that little cubed, the cube root is very clear. That's not a multiplier, it's an index. But we are done. You can stop there. Okay. That was kind of a doozy. So watch out. Sometimes if there's like 3 functions, you're looking at probably product rule and some chain. Okay. Number 9. You want to try it? Okay. Does this one, are we looking at product and chain? No, it's just chain rule. Okay. All we need is what is F and what is G. Once you get those straightened out, you'll be good to go. It's just a matter of figuring it out. What do you think? Sine 5x? Okay, the exponent 5 is part of F. Something raised to the 5th power is what? X to the 5th. And then what's been stuffed into the x position being raised to the 5th power is sine. The hardest part is pulling apart your F's and your G's.
Why is there an X?
X in front of the 5, because that's an exponent. This has something being raised to the 5th power. And that something that's being multiplied 5 times is sine. Because isn't it sine x times sine x times sine x times sine x times sine x? So it's something being raised to the 5th power, which is, that something is your g of x, which is 5. I think so. Yep. Yeah, that works. You could have even just left it, actually. No, I can't see upside down. Yeah, you could have just left it right there. That 5's in the front, so that's also good. But they're both fine. What do we have, guys? Make sure you have y prime or dy dx equals. Good. You're done. Box that up. Oh, that's it. That's it. Box it up. Good. Yep. You can leave it just like that. I'll put it up on the board. So we get y prime is 5 sine x to the 4th times cosine x. Is that the same as saying 5 cosine x times sine to the 4th? Yeah, that's the same. It's the same. Commutative property, we can multiply in any order. Okay? Number 10. What do you think? We have product rule and quotient rule. Oh, this might be double chain. Oh, let me think about this one. Yay, I love hard math. This is fun, guys. So fun. Okay, so if it was just cosine cubed, it would have been like the last problem, right? But this parenthesis is actually inserted into the cosine. I think it's double chain. Weird. Okay. Huh. Oh. I think it's double chain. F of x.
Wouldn't x squared minus 1 be taken in place of the x to number 9?
Yeah, but then you're right, it does take the place of the x here.
Could just be like
But then you have a chain in here because you have this quadratic function stuffed into, wow, okay. So, this is going to, f is x cubed, right? Okay, g is the quadratic, well, it's cosine x squared minus 1. Now I might make up another function, h, because we have a double chain. H would be x squared minus 1. I would start on the inside first, probably, because we need to know the derivative of g, but you have to do the chain rule on the g to get the derivative of it. Double chain. You look like you're in shock. This is cool. Ah, so fun. Okay. It's like a big puzzle, and you feel so accomplished when you finish it. Okay.
There's only one more.
I'm sorry?
Why don't we break g of x?
Okay, we can. If it helps you. J. The other one is cosine, right? So, let's see. What's on the... This is the stuffing, though. So if we're going to write the 2, and the stuffing is x squared minus 1 and cosine x. Okay, so using these, it will give us g prime. So h prime of x and j prime of x. Margarita, what would h prime of x be? Oh, on the j. Yeah, the j would be 2x. But what about the cosine x? What's the derivative of cosine x? That's the one that changes the sign. Yep. Negative sine x. So for g prime, we have to apply the chain rule. Now we have all the pieces to do that. Okay. F prime, which F prime for us this time is our h prime function. Negative sine times, what do I stuff in? The jx squared minus 1 times j prime. which is 2x. If you want to rewrite that, I would write negative 2x sine x squared minus 1. F prime, luckily, is very nice. Okay. Rebecca, what's F prime? Good. Okay, so now we have all of the stuff we need to go and do a chain rule a second time to get dy dx. You want to finish it? Oh, nope, that's right. Sorry, I thought I missed Rosan. That's why. Okay. When you think you have it, raise your hand. I can come check you. See if you're right. Added to a chain rule on this guy because we have quadratic function stuffed into the trig function. So I made up 2 more letters, H and J. The turkey, the outside was cosine x. The stuffing is x squared minus 1. Yeah, because I'm trying to find the derivative of g. In order to do that, since I have a composition of functions, I have to do another chain rule. So my outer guy was cosine x, my inner guy was x squared minus 1. Took the derivative of both of them, and this was all the chain rule using the derivatives.
This is all for the derivative of g.
Yep. Yep. So that is f or h prime of j times j prime. Yep. Okay. All right. Think you got it? Yeah, it's essentially what I have. I just have multiplied 3 and a negative 2x together to make negative 6x. But it's essentially what I have. I mean, it's equivalent. It is equivalent. Okay. I think you're missing a cosine. You dropped a cosine. Yeah, go back through and look. But it's almost there. You're missing a squared. You're really close, but we're missing a squared. You're also missing the squared. Okay, this one's difficult. Let me come up to the board so everyone can see. So, d dx of f of g of x equals f prime is what? 3x squared. So I'm going to put parentheses because I'm going to stuff in there. What do I stuff? G, which is cosine. That's your cosine, Gisu. Cosine x squared minus 1 times g prime negative 2x sine x squared minus 1. Technically, if you stop there, it's mathematically equivalent. But I do see I have a 3 and a negative 2x multiplying, so it'd be negative 6x. We generally like these squared. You can see in the problem, it doesn't come after the square root or after the part. It comes right after the cosine. So cosine, if you put all parentheses squared, I think that's equivalent. But I wouldn't do the squared right after x squared minus 1. It goes cosine squared x squared minus 1 times sine x squared minus 1. Does that make sense? But you're really close. A couple people just were either dropping the squared or had it out on the end, and then just don't drop that cosine. Okay. Yep, please. I can tell you in this next one I see three things. I see a trig function, I see a square root function, and I see a linear function. Double chain. Double chain. Try it out. Okay, so what do you think's F? What's on the outside? Because F's the outside. Sine, yep. Sine x. And then stuffed into the x position is what? Square root of, which would be the same as 5x minus 1 to the 1/2 power, right? So you can take the derivative of it, but that is a chain rule in itself. Because it's a linear function inside of a square root function. So it's a chain rule. So it's like the last problem we did, you can make up an h and a g function.
Would this one, do you guys see that, or is that wrong?
That's right.
And now,
To find g prime, you have to do the derivative using a chain rule, because you have a linear function stuffed inside of a quadratic, or a square root function.
So wait, is it
Sine x, and this is square root 5x minus 1.
And then what would you do for after 1/2?
No, so these, h of x was doing chain on g of x.
Oh, so you just find the chain rule.
So what's on the outside again of g of x?
1/2.
X to the 1/2, yep. And then the j function's what's the stuffing.
Oh.
Because we have to do the second chain to find the derivative of g. Good, and then find the derivatives of each of them, and then apply the chain rule, and you'll have g prime. And you apply the chain rule again, and you'll have y prime.
So you only do this when your trig function is to a power. When it's to a power, it's x to that power, but when
Yeah.
it's not, it's just sine x.
Right.
Okay.
What? In anything in construction, in any design, in engineering, in electrical work, in... Let's see. This is number 11. So, prime. 5/2. Yes. That one's yours. I was like giving you my good job. Okay. All right. Let's get you a little start, a little boost here. F of x, your outside, your turkey, or your turkey with stuffing. Sine x. F of x is the stuffing. Root 5x minus 1. G. Yeah. The derivative of f of x is the easy part. That is just cosine x, right? It's the derivative of g that causes an issue, because you have to do a chain rule on that guy, because it's a linear function stuffed inside of a square root function. So that's when I create two more functions, and these are applying to g. What's the outside function on g of x? X to the 1/2. The stuffing is 5x minus 1. H prime is 1/2 x to the negative 1/2. That's an easy thing to forget or to get wrong, is the exponent is 1/2 minus 2 over 2, which will be negative 1/2. J prime of x equals 5. So now you can do g prime of x. G prime of x was h prime. What's h prime? 1/2 x to the negative 1/2 with j stuffed inside times by j prime, which would be, we could also say this was equal to 5/2, and you can even put square root 5x minus 1. Okay, and the last part, derivative of f of g of x, chain rule again now that you have all of the top filled out. F prime cosine, and then where x was, we put parentheses because we're going to be plugging in. What plugs into f prime? The g, which is square root of x minus 5, or 5x minus 1, times, not g of x, g prime of x. So the 5 over 2 root 5x minus 1. You can stop there if you want. You could move this second fraction 5 over 2 root 5x minus 1 in front of the cosine. Yeah, like, nah, too much work. Cool. Yeah? For all of it? Okay, I'll come look at that. Okay, try the next one. Oh, the next one's nice. Other than the derivative of cosecant kind of gets a little messy. Yeah, so this one, let's see. So you have cosine root.
I know, it's close to it.
Yeah. Now, you can't do that cancellation that you did because this isn't part of cosine.
Yeah, so that has to stay.
Because this isn't, you can only cancel when everything's being multiplied. And this is multiplied 2 times that, but this is cosine of, it's not multiplication, it's cosine of root 5x minus 1. Yeah, so these can't, that's not legal, those can't cancel out.
And then times chain rule, because that's what I did.
Okay, because this is not sine times this. This is sine of this.
Oh.
And this is x squared times that. That's why we did product rule. So with the trig functions, what comes after the sine or the cosine is not being multiplied. It's of. Okay. Number negative 10x cosecant 5x. Yes.
Yeah.
Way to be. You got the same thing. Good job. Just because you got that right. Cosine. Yeah, it's the same. Yep. Good. You got it. Rita, you had your hand up?
Yeah.
Check.
Do we plug into this x too, or no?
No, just the first x. So this is almost done, except for there's supposed to be a negative sign, I think, there. And, yeah, you don't plug into this x.
I just want to see it.
So that's just x, and I think that's a negative. You have your, yeah, cosecant, it's a negative.
Okay.
But other than that, you're good. You only plug into that first x. Good. Okay, good job. Start working on the homework part of chain rule.
We should have thought it SVP. Then we can practice that whole thing. Give us the starter next time on this. Because we're all going to forget it. Jonathan, what do you think?
Everyone's like, no.
Yeah, thank you. This will be the last thing we put this together. Isn't it a good idea to offer extra credit, like for starters, one more starter that gets extra Okay. Teaching how to chain roll faster than a teacher thought we would. We should get extra credit.